Let's see if the curve 1 over 1 plus x squared has a finite amount of area underneath it or not. So here we have the graph 1 over 1 plus x squared, and our goal is to integrate this over the entire domain. So we will integrate from minus infinity all the way to positive infinity. And we'll see if we get a real number out of this. So the way that we're going to do this is by approximating. Let's say we're going to integrate from m all the way to, let's call it n. So I'm going to need two different integrals here because I'm going to have two different limits that I'm going to send to infinity and minus infinity. So we will write this as the integral from m, because that's what's on my left-hand side. And I need an arbitrary point in the middle. Choosing 0 is a good choice. So we'll integrate up to the origin because that makes for some easy algebra. And then we will eventually want to send m all the way to the left. So all the way to minus infinity. And our next integral will pick up at 0 and go to n. So we're going to integrate from 0 up to n. And then after we find that area, we're going to send in to positive infinity. So we'll send that all the way to the right. And we'll see if we get something finite. So pause the video now. Ask yourself how you would tackle both of these integrals. So if you said a tangent substitution, I think that's a correct move. So we have the limit as m goes to minus infinity. The antiderivative of 1 over 1 plus x squared is the arctangent function, which needs to be evaluated between m and 0. And obviously, the next function has the same antiderivative, so this will be limit as n will move eventually all the way to the right. Arctangent x evaluated between 0 and n. Okay, so we have limit as m will go to minus infinity, arctangent of 0 minus arctangent of m. So this right here gives me the area underneath the function between 0 and m. And then after I take the limit, that will give me the area from minus infinity to 0. All right, and over here, we have limit as n will eventually go to positive infinity, arctangent of n minus arctangent of 0. Now let's take some limits and see if we get a real answer out of this. So the arctangent of 0, that's just a constant, so the limit doesn't really care about that. It just moves past it. The arctangent of 0 is 0. So I've got 0 minus limit as m goes to minus infinity, arctangent m, plus limit as n goes to positive infinity, arctangent of n, minus, and for the same reasons, this arctangent of 0 is just a constant 0. Okay, so here we get 0 minus. If you think about the arctangent function, you can either think of that as its own thing. The graph looks something like this. And as you go infinitely in the left, you've got a horizontal asymptote at minus pi over 2. So the arctangent function, as you move infinitely to the left towards minus infinity, approaches the value of minus pi over 2. So we have minus pi over 2 there. Or you can think of that, what angle do I need to give myself a tangent of minus infinity? That's when your cosine is infinitely small. So the angle is pointed straight down at minus pi over 2. All right, and then here we have limit as n goes to infinity of arctangent. So again, you could look at your arctangent function, and as you go to infinity, you approach the horizontal asymptote of pi over 2. Or a different way of thinking about that is, what angle do you need to have a tangent function equal to infinity? That's when you're pointed straight up at pi over 2. But either way you think about it, this is pi over 2. And then just copy down that minus 0. So finally, we have pi over 2 plus pi over 2, or pi. So the area underneath this function 1 over 1 plus x squared is finite. The integral converges, and it converges to the value of pi.